Okay, now let's solve question number 12 of IIT JAM Mathematical Statistics 2005 question paper. So question is limit n tends to infinity 1 upon 2 raised to the power n upon 2 gamma n upon 2 integral n plus root 2n to infinity of e raised to the power minus t upon 2 t raised to the power n by 2 minus 1 dt equals. Okay. So first of all, this is very complicated function. So if you can recognize it, so it is the PDF of chi-square distribution with n degree of freedom. So if I will write it, so it is like this is equal limit n tends to infinity n plus root 2n to infinity of we can say it's a f x dx. So x is here chi-square distribution with n degree of freedom. So you have to first recall that the PDF of chi-square distribution, this is fx you have here is uh, 1 upon 2 raised to the power n upon 2 gamma n upon 2 e raised to the power minus t upon 2, or you can write x upon 2 x raised to the power n upon 2 minus 1. So this is PDF of chi-square distribution with n degree of freedom. So what we can do, so this is if we extend it, so it is like limit n tends to infinity probability x more than n plus root 2n. So let's write here, so it's a limit n tends to infinity, it is probability x more than n plus root under 2n. So if we can make it standard normal, so we can subtract both sides. So if x has a chi-square n distribution, then expectation mean is n and variance is 2n. So this we know already, है ना? So if x has a distribution chi-square n, then mean is n, variance is 2n. So a standard deviation of x will be square root of 2n. So let's make it normal. So what we can do, subtract both sides. So x minus mean ex, so it's a n, x minus mean upon standard deviation, it's a root 2n. So we'll get more than it was n plus root under 2n. Okay, so we'll subtract n mean and divide root 2n both side. So what we did, both side here, both side we subtracted n which is mean and divided by standard deviation just to normalize it. So what we'll get here, limit n tends to infinity probability, and now this random variable has a normal distribution. So let's write one more. So it says, we suppose it's a z, so z is more than this is 1. So directly I will write it, so limit is not required now. So I used a central limit theorem. So it says x minus ex upon root standard deviation has a standard normal. Method converges in like it says. So if we have x any random variable, so x minus mu upon sigma, okay, converges in distribution to z, and z is what? Z is normal 0 1. So this z has now distribution normal 0 1. So this we can write 1 minus probability z less than equal to 1. The 1 minus phi z. So this phi is the CDF of standard normal. And from the standard normal table, we can calculate phi z. So z here is 1, sorry. Means this is 1. Since z it was probability z more than equal to 1. So we can write it 1 minus probability z less than equal to 1. And this notation for this is phi 1. So what is phi? So phi, like phi x is nothing but probability z less than equal to x. So phi 1, and we know the value of phi 1. So in exam it will be given. So here we can check, like, yes, so we have a table, so we can check it. So in this table, if you can see, so for z is 1, so value is this, so it's 0.8413, so it's a 8413. So let's calculate this. So what we have, it's a 1 minus 0.8413, right? So after simplification we'll get 0.1587. So please check the calculation. So it is 0.1587. This is D is the correct option. So for this question, we had given integral of PDF of chi-square n. So it was nothing but this, probability x more than n plus root 2n, and x has distribution chi-square n. Then we subtracted both side mean divided by standard deviation. So we applied central limit theorem. So this random variable will be a standard normal, and then from the standard normal table we got the value. Then we have our answer 0.1587. So the option is correct. Thank you so much.